The most powerful company in artificial intelligence doesn't build AI. In the history of technological dominance, every era has tended to be shaped by a dominant infrastructure layer. IBM controlled the mainframe ecosystem. Microsoft dictated the operating system standard. Apple privatized the mobile era, and ASML monopolized lithography. This is the sequence of modern civilization, a ladder of dependencies. But today, we face the most advanced expression of that lineage to date. Within the Silicon Node Intelligence Framework, Node 003 examines Nvidia. For Wall Street, this is the most valuable hardware company in the world, with fiscal year 2026 revenues exceeding $215 billion. But for the geopolitical strategist, it is something far more consequential. It is the global control layer that converts electricity, capital, and software into computational sovereignty. We are no longer discussing just a company. We are discussing the emergence of a technological framework where the boundaries of a nation's power are increasingly defined by its access to high-performance silicon. Today, we will not analyze how a microchip functions. We will examine how a single entity in Santa Clara has become a primary organizing principle. We will dissect the transition from the era of realpolitik to the era of computepolitik, where the standard of civilization is no longer solely written in treaties, but in the architecture of a GPU.
Chapter 1: The Constellation and the Map of Power.
The greatest analytical error of the 21st century is to isolate Nvidia as a solitary giant. True power is rarely merely massive, it is systemic. Nvidia is the visible node of an industrial constellation divided into 5 critical, interdependent layers. They control the highest tier, architectural design, yet they manufacture nothing physically. They operate as a fabless entity, delegating the physical reality of fabrication to TSMC foundries in Taiwan. Utilizing the most advanced nodes, this creates a trifecta of dependence: the design from California, the lithography from the Netherlands via ASML, and the manufacturing from an island at the center of intense geopolitical friction. However, the bottleneck has moved. It is no longer just about printing transistors. It is about advanced packaging. Nvidia requires an exclusive process known as CoWoS chip-on-wafer-on-substrate. TSMC explicitly describes this as a foundational platform for high-performance computing. It is a critical structural bottleneck of the industry. Without this specific Asian-dominated process, the scaling of the world's most advanced AI clusters becomes significantly constrained. If we fail to map this entire constellation, Nvidia's power seems merely enormous. By viewing the complete infrastructure, the reality emerges. Nvidia has evolved into a central coordinating force within the current innovation stack. They have achieved a form of vertical influence, where players across the spectrum from sovereign states to cloud providers must closely synchronize their roadmaps to Nvidia's release cycle.
Chapter 2: From Product to Compatibility Regime.
Nvidia's competitors Intel, AMD, and heavily subsidized international startups invest billions attempting to design a faster silicon chip. Yet, they often struggle because they are fighting on a traditional hardware battlefield, while Nvidia is competing at the level of software ecosystems and developer adoption. Nvidia evolved beyond being a traditional hardware-first company years ago. Today, it functions as a compatibility regime. The foundation of this digital architecture is CUDA, the software platform that allows processors to translate the complex mathematics of artificial intelligence by fostering an ecosystem utilized by millions of developers globally. Nvidia has led a generation of engineers to predominantly build within its ecosystem. This creates a profound degree of path dependency. When a government or a corporation purchases from Nvidia, it is not merely acquiring a physical component, it is adopting a standardized computational language. The cost of switching to a competitor involves not just hardware procurement, but the immense institutional friction of rewriting extensive codebases and retraining a specialized workforce. While the silicon itself is the vessel, Nvidia's most enduring barrier lies in the institutional and technical inertia embedded in its software stack.
Chapter 3: National Security and the Geopolitical Tourniquet.
This profound integration shifts the analytical paradigm. Nvidia has transcended its status as a commercial technology provider to become recognized as a form of high-impact dual-use infrastructure. Next-generation GPUs are fundamental to modern statecraft. They process satellite intelligence, optimize cryptographic analysis, and enable sophisticated software-defined warfare. In global defense departments, the priority is the digital twin. Advanced compute allows for the simulation of complex theaters of operations, modeling kinetic variables and logistical stress tests before any physical deployment occurs. This realization has accelerated the era of sovereign AI. Nations like Saudi Arabia, the UAE, and France have determined that relying entirely on foreign cloud infrastructure is a strategic vulnerability. They are building state-backed compute clusters to ensure their national data and algorithmic development remain under domestic jurisdiction. Consequently, the US Bureau of Industry and Security, BIS, has utilized this architecture as a geopolitical lever. By enforcing rigorous export controls on advanced chips and high-bandwidth memory (HBM), Washington aims to constrain the technological acceleration of its strategic competitors. For Beijing, establishing a viable alternative to this ecosystem is no longer just an industrial goal. It is a critical, long-term imperative for technological sovereignty and state resilience.
Chapter 4: The Fragility of the Moat, Training versus Inference.
Yet, no market position is invulnerable. Tracing the anatomy of capital requires a clinical audit of its fragilities. Nvidia's current dominance faces significant systemic pressures. First is geopolitical concentration. The heavy reliance on the Taiwan Strait remains a profound structural risk. A major geopolitical disruption in the Pacific would trigger a severe and immediate disruption across the global tech supply chain. Second, Nvidia's largest clients, the hyperscalers, are simultaneously its greatest long-term competitors. Microsoft, Amazon, and Google are investing heavily in proprietary custom silicon to mitigate the margin-draining Nvidia tax, while Nvidia's Moat in training massive foundational models remains incredibly robust. The strategic battleground is expanding into Inference, the daily execution and running of these models. As AI deployment scales globally, inference costs will dwarf training costs. It is precisely in this high-volume, highly specific inference market where chips, like Google's TPU or Amazon's Inference, offer viable alternatives. Here, the absolute necessity of third-party premium silicon faces its most realistic threat of gradual erosion.
Chapter 5: The Energy Wall and the Geopolitics of the Watt.
But Node 003 faces a structural constraint that even the most advanced architecture cannot bypass: the physical limits of the energy grid. The race for artificial intelligence is inextricably tied to the generation of electricity. Today, Nvidia's long-term valuation depends heavily on energy efficiency. We are transitioning from an era defined by how many chips can you procure to how many megawatts can you sustainably power. The International Energy Agency projects that data center power demand could more than double by 2030, creating unprecedented strain on global infrastructure. The expansion of this industry is increasingly regulated not by code, but by the availability of baseload power. This reality merges technological geostrategy with energy policy. Regions with abundant, stable, and naturally cooling energy profiles from Iceland to the Nordic countries are strategically positioning themselves as critical hubs for global computation. Nvidia's Blackwell architecture is fundamentally designed to address this, optimizing relentlessly for performance per watt. To sustain this growth trajectory, tech giants are accelerating a nuclear pivot, exploring investments in small modular reactors (SMRs) and securing direct access to nuclear plants. Silicon is now a primary driver of national energy policy. In the coming decade, operational supremacy will belong to those who can power the infrastructure without destabilizing the grid. The watt has become the fundamental currency of artificial intelligence. As we close this briefing on Node 003, the defining question is not what its market capitalization will be next quarter, but rather, how is this architecture fundamentally restructuring global power? Historically, nations built standing armies to project influence and protect their sovereignty. In the 21st century, the sovereign state must build standing compute. We are entering an era where national resilience is inextricably linked to inference capacity and energy security. The state and the corporation are now bound together by the relentless demand for silicon and megawatt hours. Nvidia does not own the future, but it has engineered the structural foundation upon which the future must be built. Power is no longer exclusively measured by the control of land, sea, or airspace. It is measured by the control of the algorithmic infrastructure that models reality itself. In this new computational order, those who architect the node will disproportionately shape the systems through which others operate. This has been a Silicon Node Intelligence Briefing. Follow the money. Follow the nodes. If you value this level of industrial intelligence and want to stay ahead of the disruptive trends shaping 21st century and beyond, join us.
We are Silicon Node Reports, and this was Nvidia and the regime of computational sovereignty. Subscribe to Silicon Node Reports. Let's decode the future of the world's most critical supply chains together. Silicon Node Reports, the infrastructure of global capital.